Hey guys, so today we're going to be talking about, we are going to be working with our packet. So I have done a few problems for you so that you guys can see what I did. You will need your periodic table out that I gave you. Now, I don't want you to worry about this charge section. So because we're not worrying about the ions, we're actually going to go ahead and, do you see how it says aluminum 3 positive? That means that it has a 3 plus charge. So we're actually not going to worry about that. So we're going to go ahead and erase that. Anytime you have an element that that is an ion of that, remember an ion is an atom or group of atoms that have an electrical charge. Well, we're not going to worry about the electrical charges. So we're just going to take those off. And down here, the last one had a 1 plus charge. We're going to just go ahead and change that to F. Okay, so we're just going to practice the basics of finding the protons, neutrons, and electrons. You guys should be aware of this. Oh, and over here, this is actually 56. And over here, this is 7 minus 3. 3, 4 is 4. So we're going to change that. We're going to change this. That doesn't even matter. Yeah, this is a neutron, sorry. Okay, so the very first problem, it tells you the number of protons. Remember that when you have the number of protons, that is equal to the number of electrons, always. The number of protons and electrons in an atom is also related to the atomic number. So remember, the atomic number, if the number of protons is 8, then guess what? The atomic number is 8. So once you find out the atomic number, you can actually go to your periodic table and look at the atomic number. The atomic number is the top number. So that element is oxygen. I'm going to look at the atomic mass, which is the mass that has not been rounded. The atomic mass is 16.00. Now, because it says 16.00, I can't really round it. When I round this, I can get the the mass number. And so if I round 16.00 up or down, it's this one right here, tenths place, is obviously 0, so this number is closer to 16. So I put 16 here. So in order to find the number of neutrons, I actually have to take the mass number and subtract it from the atomic number. Again, this shouldn't be new for you. We've done this already. So I'm going to take the mass number, 16, and I'm going to subtract the atomic number, which is 8. So the number of neutrons is 8. Now, all of these have the same amount. That's not going to happen every single time. So let's do aluminum. Again, I went ahead and crossed that ion. It's not an ion anymore. It's just a regular aluminum atom. So it gives us the element name. So I'm going to find the atomic number, because once I find the atomic number, again, I can fill out a lot of this chart. So the atomic number of aluminum is 13. I look below to the atomic mass or atomic weight, and it's 26.98. I'm going to look at this tenths place and I'm going to say, oh, that is greater than 5. So 26.98 is actually closer to 27. So I went ahead and wrote 27 here, okay? And then I moved on to my protons. Again, the atomic number tells you the amount of protons and electrons in the atom. So if I have my atomic number is 13, guess what? My number of proteins is 13, and my number of electrons is 13. Shh. So now I need to find the number of neutrons. So how I'm going to do that is I'm actually going to take my mass number, which is 27. Let's go ahead and fix this. Okay, my mass number is 27. So 27 minus the atomic number, which is 13, is going to give me 14. So the number of neutrons in this neutral atom is 14. Okay, so let's do one more together. So PB is lead, and it has an atomic number of 82. So I'm going to go ahead and write 82. Again, it's the top number, the atomic number. So What does the atomic number tell us? It tells us the number of protons and electrons. So I'm going to come over here and go ahead and write out 82 protons and 82 electrons. It's neutral. There is no charge. The atomic mass for lead is 207.20. Okay? Now, I'm going to look at my 10th place and I'm going to say, oh, it's not greater than 5. So I'm going to make this mass number stay the same. So it is closer to 207. I'm then going to take 207 and subtract it from my atomic number. So I'm going to come over here to the side, minus 82, 5, that becomes a 10, that becomes a 1, 8, 9, 10, 2. So I have 125 neutrons. Okay, so you're going to do that all the way down the page. All right, so let's go to the next one. Next page. The next page is our Bohr models. So you're going to be having to figure out the electron configuration for silicon, magnesium, argon, and nitrogen. And I've actually done, we've been practicing this, so I'm hoping that you guys have a really good base knowledge. Just a reminder, the first orbital can only hold 2 electrons. The second can hold 8, and the third can hold 8. Once you hit those 2 electrons, remember you have to move to the second orbital, okay? So when you're doing Bohr models, you need to find the atomic number. So I found silicon on the periodic table, and it has an atomic number of 14, all right? So I go ahead and I think, okay, the atomic number tells me the amount of electrons. Bohr models show the total amount of electrons. So what do I know? First orbital can hold 2, so 1, 2, second, and then I just start counting. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, there's 8, so I need to move to the third. 11, 12, 13, 14. So that is what you're going to do with every single one of these. All right? Next page. Okay, so this part this is the number of atoms in a formula. So how do you calculate the number of atoms in a formula? All right, so when we are counting atoms in a formula, there are just some, or how many atoms are in a molecule. If you're given this, NaCl, I know that there is one molecule of NaCl, so that means that there is one sodium atom and one chlorine atom. So the total number of atoms in the formula is 2 atoms in total. So I'm going to be looking, so this would be 2 because there are 2. There's one here and one here. So if there's no number to the right of an element, meaning like see right here, this is a subscript. If there's no element to the right of that element symbol, there is one atom of that element. Rule 2, if the same number to the right of an element, this is called a subscript, tells us how many atoms of the elements that there are. So just like when we were completing the ionic bonds, you notice that we had to add an iodine to magnesium, or we had to, so when we did that and we wrote it out, we said MgI2. Okay, so that told us that there was 2 atoms of that element. So anytime you see a subscript here, you know that there is that same number of atoms. Okay. Rule number 3: if there are elements inside of parentheses, so PO4, see how there's a parentheses? You're going to multiply the number of each element inside the parentheses by this small number after it. So it's kind of like the distributive property in math. So we know that there are a total of two phosphorus atoms, and there's 4 of here already. So what's 4 times 2? 8. Okay, so let's look at number 7, and again, we'll look at it together. So here we have calcium, we have phosphorus, oxygen, and we have all these subscripts. So remember, first rule, this right here, if there's a number to the right of the element symbol, that tells us how many atoms of that element there are. So we have 3 calcium. So I'm going to go ahead and just put 3 up here. Okay. We have now we have a parentheses. So again, I'm going to distribute this over here. So we have 2 phosphorus, and then I'm going to distribute this over here. And 4 times 2 is 8. So we have a total of 8 there. So now I'm going to add them all up. 8, 9, 10, 11, 12, 13. There is a total of 13 atoms in that chemical formula. Okay? If there is a number directly in front, I don't think there's any here. So let's see. Let's see if there's any additional things that I need to make you aware of. Okay, so this one right here, again, we'll do one more. We'll look at number 13, and we have 3 hydrogen atoms. I'm going to put 3 up here, plus how many, now there's no parentheses, right? So how many phosphorus do we have? We have 1, so I'm going to put it up above it. How many oxygen do we have? Oh, there's a subscript that tells us that there are 4. So I'm going to put 4 here. So then I'm going to add up all my atoms. 4, 5, 6, 7, 8. So the number of atoms in this molecule is 8. Okay? All right. Let's see. Let's do another parentheses one just to help you a little bit, help you along the way. Okay, so I'm going to move to number 8. All right, we have aluminum, we have sulfur, and we have oxygen. Okay, so again, I'm just going to put the total number that I have up above it. Let me zoom in. So there are 2, because this subscript tells us how many. So there are 2 aluminum plus, remember we have to distribute this 3. So that 3, how many sulfur atoms do we have? We have 3 plus, okay, and then we have oxygen, but we have 4 of them. So what's 4 times 3? 12, right? Because we have to distribute those numbers. So 12 plus 3, 15, 16, 17. So the total number of atoms in this formula is 17. Okay, I want you guys to make sure that you write these out, because that shows me that you know what you're doing. It's easier that way. Okay, so the next part of this is the number of valence electrons. So the number of valence electrons depends on what? It depends on the group number. Whatever group it's in, whatever group it is. So remember, groups are columns. Groups, families, or columns is going to tell you the amount of valence electrons. Valence electrons are those electrons that are in the outer shell. So potassium, I'm going to bring out my periodic table again. And here is my periodic table. And potassium is K, and it is in group 1. So because it's in group 1, how many valence electrons does it have? There's all of these in group 1 have 1 valence electron, okay? All of these ones here in group 2 have 2 valence electrons. And again, those valence electrons are what allows those chemical bonds to happen. So I'm just going to put 1 there. All right. I feel like you guys are really comfortable with that, so I'm not gonna go into any further detail about that. All right. So this is atoms and molecules, and again, this kind of has to do with the number of atoms in a formula and how many are there. So it's the same exact thing that we did up here, except for you're going to write it out. So I've already done. There's already one filled out for you. So we have magnesium oxide, okay? So magnesium oxide shows us that there are 2 number of elements. Here's one element and here's another. We know that there are 2 elements because the element symbol is represented by a capital letter, okay? Remember that the formulas or element symbols can be represented by an uppercase and a lowercase or just an uppercase. So I know that in H there's 2 elements. I know that there's hydrogen, carbon, and oxygen, so there's 3 elements that we're going to be dealing with. And in this one, I know that there is carbon, hydrogen, and oxygen, so 3 again. Here, I have 1, there's a capital letter. I have 2, there's another capital letter. I have 3. So when you see a capital letter, it's like starting, just like a sentence. You always capitalize the start of a new sentence. So same with elements, you always capitalize when a new element is there, okay? So you're going to write down the number of elements. So in magnesium oxide, I have a total of 2. And then you're going to tell me the number of atoms of each element. Again, remember, if there is a subscript, or a number below the element symbol, that tells you the number of atoms of that element, okay? So MgO, magnesium, there's 1. Oxygen, there's 1. Total number of atoms in this element or total numbers of atoms in one molecule, 1, 2. You're going to add those together, and there are 2. So again, it's a similar, very, very similar to this one, okay? All right, let's go ahead and move on to the next one. Okay, so this is just identifying the type of chemical bonds that are within that, if it's ionic or covalent. So the very first thing is what makes an ionic bond. Remember what makes a covalent. Covalent, sharing is caring. And remember my letter C that I showed you, non-metal, non-metal. So I know that covalent bonds are between a non-metal and a non-metal. Okay, remember ionic, I have 1 from the non-metal side and 1 from the metal side, and I form an I. So an ionic is a metal plus a non-metal. So this is about looking up on the periodic table and determining whether or not, I have all the answers here, sorry, whether or not this atom is a metal, which it is, and this atom is a non-metal. So anytime you have a metal and a non-metal together, you know that it is an ionic bond. You know that it has some type of charge, okay? Same thing here. You're going to look at the two atoms or the 2 elements in each one in the formula, and you're going to say, oh, carbon, well, that's a non-metal. Oh, oxygen, that's a non-metal. So I'm going to put this is a non-metal plus a non-metal, so that has to be a covalent bond. Okay, so hopefully you guys again understand how to do that. All right, so this one is where you're probably going to have to get a scrap piece of paper. This is writing the formulas for the compounds. Okay. So let me go grab a piece of paper and I'll be right back. All right, so I got my piece of paper. All right, so we practiced a little bit of this on Friday. So you are going to be writing the formulas for compounds formed from these ions. So remember that compounds form when they want to achieve a full outer shell. When they achieve that full outer shell, it makes the atoms very, very stable. And they want to be stable. They don't want to be all crazy, okay? So atoms can do this, like I said, in two different ways. So they can do this by either gaining electrons, losing electrons, or in a covalent bond, sharing electrons. But we're actually going to be writing ionic formulas. So ionic means they're going to have a charge. Remember, there's going to be, because it's between a metal and a non-metal. So they're either going to be gaining or losing. All right, so we're going to look at sodium chloride. And remember, I said the very first thing that you want to do is you want to write the elements. So I'm going to go ahead and write, I'm going to get a blank piece of paper. And I'm going to write Na plus Cl. Remember, we did this? Then I'm going to draw the Lewis dot structure. Remember, the Lewis dot structure is not the Bohr model, it's just showing the valence electron. So how I'm going to do that is I'm going to look, remember the valence electrons, remember the group number tells us how many they have in the outer shell. So I'm going to come over here and I'm going to look at chlorine. Chlorine is in group 17, but we're going to say 7, okay? It's in group 7. So that means that they have 7 valence electrons. Sodium is in group 1. So that means they have 1 valence electrons, okay? So we have our example. I'm going to go ahead and create my Lewis dot structure. So there's 1 valence electron for sodium. And we have 1, 2, 3, 4, 5, 6, 7 for chlorine. Okay, so again, sodium is going to give up an electron to chlorine. So this is going to have this means that it is Na plus, and because chlorine gained an electron, and electrons are negative, I'm going to put Cl negative, okay? Now, because these are represented by 1, I'm just going to write the formula NaCl. And I know that this is positive and this is negative because a metal and a non-metal coming together creates a chemical bond, because a positive and a negative come together and because opposites attract. All right, so I'm going to go back to my formula page and or my packet, and I'm going to write the chemical formula for NaCl. So NaCl. Okay, all right. So now let's look at number 7. So we have, again, I'm going to write out my elements. So we have Ag plus we have silver plus oxygen. Okay. All right. Silver plus oxygen. So silver is actually a transition metal. All right, sorry. So this is a little bit, you have to actually think about it. So remember when you have a 2 negative, that means that that oxygen atom gained 2 electrons. 2 of them, right? So if that oxygen atom gained 2 electrons, you would write AgO, because a silver actually, and this says plus, so that means that it gave away 2. So if it gave away 2 okay, I'm sorry. Okay, so we have the formula Ag plus, and remember that means 1, O2 negative. Okay, so we can, this Ag, because it's a transition metal, this is telling us that it is going to be giving away 1 electron. This is telling us that oxygen is going to be receiving 2 electrons, right? Okay, so again, I would start with the Lewis dot structure, just showing what this is showing. So Ag, because it's a transition metal, we're really not for sure of configuration. Sometimes it can be all wonky, like I said. So I went ahead and just drew Ag with 1, and it gives 1 away to oxygen, okay? But notice that silver is very, very happy, but oxygen is not. It still needs one more electron. So in order to do that, what you have to do is you have to create another Ag, and it's going to give away an electron, okay? So how would you write this? How would you write this formula? Well, now you're going to count up your atoms. So there are 2 silver atoms. So I'm going to write Ag2 and 1 oxygen atom. So now they are happy. Okay. So I wanted to also show you another way, because over time it's going to get really frustrating. You're not going to want to draw out this every single time. So there's actually another way that you can figure out the chemical formula for ionic compounds. So the first way is you're just going to write it out. So I just wrote out Ag, O2 negative. And remember, with ionic bonds, we have to have equal numbers of positives and negatives, because opposites attract. If we have more negatives than positives, then it's going to have a negative charge. If we have more if we have more positives than negatives, it has a plus charge. If we have more positives than negatives, it's going to have a negative charge. Well, we want to get these to be 0. We want to get them to have no charge, because when they have no charge, they're happy, they're stable. Okay, so I'm going to look over here and I'm going to say, okay, well, how many more silver atoms do I need in order to get 2 positive? We already have 1 right here. So, but we need, this is 2 negative, so I need at least 1 more. I'm going to rewrite this. So now I need 1 more silver. So when I do 1 more silver, I now have 2 positive over here and 2 negative over here. And again, I'm going to count up my atoms. So I have 2 silver atoms, so Ag2, and 1 oxygen atom. So that is, again, the same way as here. So I'm going to start transferring it over to this way of doing it, because I don't want you to have to draw the Lewis structure every single time. If you want to do the Lewis structure every single time, then you are more than welcome to. All right, so let's look at this one. Number 13. We have Cr3 plus and S chromium 3 plus and sulfur 2 negative. Okay, so of course these are not balanced. These are not going to cancel each other out. This is going to have we want a neutral charge. So in order to do that, I'm going to think of a number. Is there a number that 2 and 3 can both go into? Well, yeah, 6, right? So remember, we're going to add another chromium because 3 plus 3 is equal to 6. So then I say, okay, well, 2 can obviously go into 6. So I'm going to say 6 plus here. And then I'm going to start adding some more sulfur atoms. Okay, sorry. So I'm going to add S2 negative until I come up with 6 because you want both sides to be balanced. So 6 plus, 6 minus. That is balanced. So that means that this molecule will be a neutral charge and it will be stable and happy. So now I'm going to count up how many chromium atoms I have, and I have 2. So remember our subscript. Our subscript tells us how many we have. So there are 2 chromium, 2, 3 sulfur. So that's what I would write on my paper. Okay, so now another thing is when you have a plus and a minus, obviously that's 1 and 1. So 1 plus, 1 minus, it's balanced, they're going to stick together. So all you're going to have to do is write Cu, Cl. Okay, so let's look at another one. Let's do number 8. So we have Mg, 2 plus, number 8. All right, so here's my paper. So I have Mg. I really do not. 2 plus. And then we have phosphorus, 3 minus. Phosphorus, 3 minus. So again, I'm going to look at you guys are more than welcome. That's saying that this one is going to give 2 electrons and phosphorus is going to receive 3. Well, that's not balanced. There's going to be a charge. So in order for this to work, I have to come up with something that is going to be balanced. So I'm going to look at these 2 numbers and I'm going to think, okay, well, what number can both 2 and 3 go into? Oh, 6. So it's basically, again, I'm going to say P, 3 minus, right? 3 plus 3 is 6 negative. 2 can give me 6 negative, so I'm going to write Mg 2 plus, that's 4. Mg 2 plus, that's 6. So now I have 6 plus. So I have 6 plus on this side, 6 minus on this side. I'm going to count up my my atoms, and I'm going to write the balanced chemical formula. So we have M, magnesium, and we have 3 of them. 1, 2, 3. There's my subscript. Then I have capital P, and how many do I have? 1, 2. There's my subscript. So I would write the chemical formula Mg3P2. So Mg3P2. All right. So hopefully that helps. If not, go back and review how to do this. All right. Okay, so now what we're going to do is we're actually going to write ionic formulas if they give you the actual names rather than this. So this is where your periodic table does come in handy. So the very first thing, or the very first step we're going to do is we are going to find out the charge for these like the normal charge for these different ions. So we have potassium, and potassium is in group 1. So remember that if it's in group 1, then it has a +1 charge. So in order for it to show, so what I'm going to do is I'm going to come over here, and I'm going to go ahead and write K+. Okay? Because that is the normal, that's the way you would write it. Chlorine is a halogen, and it is in group 7. So because it's in group 7, it has a one negative charge. So we don't really write the 1. Remember, we're just going to write the negative. So I'm going to write Cl negative, right? So Cl negative. Okay, now we're going to take it a step further, just like you did over here. So I'm going to say, oh, those two balance out, 1 and 1. So I'm going to write the formula, and it's KCl. Okay. Number 2, I'm going to find calcium, and calcium is in group 2. So because it's in group 2, I'm going to write Ca2+. And chlorine is, again, Cl negative. All right, so this is not balanced because calcium has 1 more positive than negative. So in order to fix this, I'm going to say, oh, okay, well, all I need to do is add 1 more chlorine, and then it'll be balanced. Because then I'll have 2 on this side and 2 on this side. So how I would write it, let me go ahead and just get some paper for you and just show you that. All right, so we have Ca2+, and we have Cl negative. Okay, I need 1 more. Right now it's 2+, so they're not balanced. So I need to come over here and put Cl negative, and now I can count. So I have 2+ over here, 1, 2, 2 negative over here. They're balanced, so now I'm going to count up my atoms. So I'm going to say there is 1 calcium, and you always want to put the cation or the positive ion first when you write out your formula. So calcium, and I have 1, 2 subscript 2 chlorine. So when I come back to my paper, I should write CaCl2. All right, let's do another one. All right, so we have beryllium, and beryllium is in group 2. It's a metal and a non-metal. So beryllium is in group 2, so we have Be2+, and we have iodine, which is in halogen, and it is in group 7, and it is a non-metal, so I negative. These are not balanced. So again, I can see this pretty clearly. I'm going to have to add another iodine atom in order for it to have 2 positive on this side and 2 negative on this side. So I'm going to write this as beryllium I2, because there's going to be 2 of them. Okay? I'll do 1 more. Calcium and nitrogen. Calcium, again, I've already found it. It's in it's an alkali earth metal, so it's calcium 2+. It's in group 2. Nitrogen is in the nitrogen family, so it is 3 negative. Okay, so again, find the least common multiple between 3 and 2, and that's going to be 6. So I'm going to think, okay, again, I can come back over here, and I have I'm going to rewrite it, Ca2 plus in nitrogen 3 minus. Oh, not 31, 3 minus. Okay, so I'm going to say, okay, well, the least common multiple is going to be a 6. So I'm going to rewrite in 3 negative, right? So there's 6 negative on this side. And now I need 1, 2+, that's 4, and 6. So now I have 6 positive here. They are balanced out. I'm going to count up how many I have. I have 3 calcium and 2 nitrogen. Okay? So I'm going to rewrite it, 3 calcium and 2 nitrogen. Alright, so hopefully that helped you on that one. Alright, so you're probably going to want to take some notes down on this one. And this is, how do I name the ionic compounds? What do I say? How do I name them? So with ionic compounds, you're going to look to see if it is if it's just 2 or a binary compound, meaning that there is 2 elements and only 2 atoms. So here's 1 and here's 1. In this instance, and there's only 2. There's 1 here, that equals 2. Here on number 1, there is 1, 2, 3. So there's 3 there. So when I'm talking about the binary compounds or the ones that just have 2, how you say it is, number 1, the name of the first element stays the same. So, and that's usually a metal. So when there are two atoms only, one first element name stays the same. Second element, and the second element, you're going to change the name of the second element so that it ends in IDE. Change second element to end in IDE. So calcium chloride, sodium chloride. So let's look at number 1 or number 2. So again, first element, this is sodium. So you're going to write out sodium. So sodium. F is fluorine. So remember, we're going to change the second element to I. So we're going to say the first element, sodium fluoride. So, not fluorine, but fluoride. That shows that it's an ionic compound. Okay, let's do another one. Again, CaO. This is, we're going to look at number 7. And number 7 has only 2 atoms. We have calcium and oxygen. So how we're going to say this is we're going to, first element stays the same. So we're just going to rewrite it. So calcium. And now instead of oxygen, we're going to say oxide. Okay? All right. So hopefully, again, you would do that with numbers 3, numbers 10. Again, those are the ones that only have 2 atoms. Now, what do you do when you have compounds that have more than 2 elements? Okay, so compounds with more than 2 elements. Okay, so the very first thing you're going to do is same as last time. You're going to first element, the very first element, first element stays the same. Stays the same. Okay, 2. You must add a prefix in front of the second element when there is more than 1 atom. So that's why, so then prefix, and remember the prefix is before, it's prior to the word. So prefix in front of the second. Second element. Okay? If there's more than 1. So for example, here is mono is a prefix. Mono means 1. And again, you might want to write these down. So we have mono, let's see. Where can I add this? Mono is equal to 1. Di is equal to 2. Tri is equal to 3. Tetra is 4. See why it's so important? Math is, numbers and math are so important to know. Penta is 5. Hexa is 6. Hepta is 7. And octa is 8. Okay. All right, so there again, you're going to be adding the prefix in front of the second element. And again, this is with ionic compounds, not covalent compounds. We're still working on ionic compounds. Okay, so let's look at number 1. I'm going to notice that this right here tells me that there are more than 2 atoms. There's actually a total of 3 because there's 2 chlorine atoms. Okay, so the name of the first element is going to stay the same. So we have barium. All right, barium. Now, I'm going to look to see how many of the chlorine I have. I have 2. So because I have 2, I'm going to say barium dichloride. Okay, so you're still using that IDE. So barium dichloride. So you're still using that IDE. Okay. I guess for number 3 over here, keep the IDE. Keep the IDE at the end. Okay. So let's look at number 6. We have let's look at so again, even when there's a subscript here, if there's a subscript in after the first element, that doesn't matter. So you're going to say potassium sulfide. Okay. Potassium sulfide. Time to go. Okay, so now we are going to, again, you're just always going to name the metal. So this would, even though there's a subscript here, you're just going to say aluminum, and then again, you're going to see there's 3 of those. So you can come over here, and that is trioxide. Trioxide. Okay, so hopefully that helped you. Go ahead and name those ionic compounds.
I got away.
To naming covalent compounds. All right, so remember, covalent compounds are between a nonmetal and a nonmetal. Okay, they are sharing electrons. So, how do we name the following compounds? Well, when we use covalent compounds, we actually use just that prefix table that you just wrote out. I went ahead and added nona, but mono, di, tri, tetra, penta, hexa, hepta, octa, nano. So what we're going to do is right here. So I would not, so on this one, we have CO, okay? I would not say monocarbon monoxide. And the reason I wouldn't do that is because the very first rule is if the first element only has 1, you don't use mono. So first element, you're just, don't use mono. All you're going to do is just write carbon. Doesn't use mono because, again, we don't use that mono prefix. Also, a second rule is I wouldn't say don't double up the O's. So I'll show you what that means. Don't double up the O's. So for example, I would not write this as monocarbon Monoxide. Okay, monoxide. See how there's two O's right there? Okay, I am not going to double up my O's. So it would literally be monoxide. And you're very familiar, monoxide. Okay, so I would also not use mono. So it would just simply be carbon monoxide. Okay, because that tells me that there are one. Now, with covalent compounds, again, a nonmetal and a nonmetal. So now there's two. So the very first one, I'm not going to write mono. So I'm going to say carbon. And then I have two, which is di. So it would be carbon dioxide. Dioxide. Stop here. Okay. Now, if I have something like number 8, in which it does have two nitrogen atoms, then I'm going to say dinitrogen. There are 5 oxygen, so pentaoxide. Okay, so dinitrogen pentaoxide. So anytime this subscript is more than 1, then you are going to use the prefixes. So you're always going to use the prefixes on both the if it has more than 1 on the on this nonmetal. Just like up here on these nonmetals, you use the prefixes. All right. So writing covalent compounds. So it's the same exact thing, except for they've given you the words. So sulfur. So I know that anytime it just has 1, it's just going to use its name. So I'm going to put S. Sulfur is S. Trioxide. So that tells me that there are 3 oxygen. Okay. Let's do number 2. Dinitrogen. So that tells me that there are 2 nitrogen. So dinitrogen monoxide. That tells me that there is 1. Now, I am not. A lot of people like to put 1 there. No, do not do that. All you need is to draw the O. That is given because that tells us that there is 1, right? You do not need to put the O as the the 1 as a subscript. Okay, so that is naming covalent compounds. All right, so the back page is naming compounds mixed. That means that there are going to be ionic compounds and covalent compounds. You are going to have to determine whether or not it is an ionic or covalent. Then you're going to have to name them. So if you need to go back and look at those prefixes, or if you want to rewrite it down up here, so use what you know. So NaCl, I know that is an ionic compound, and you can put I beside it just to help you if you want to just look through first. And then, so like Mn. Mn is a magnesium, and that is a transition metal. And S is a non-metal. Sulfur is a non-metal, so this is also an ionic compound. And then you would simply just write sodium. Remember, with ionics, you write just the word first. So sodium, and it doesn't matter if they have an ionic, it doesn't matter if they have a subscript. You always just write the metal name. Metals, you always write their names. So again, manganese. Manganese sulfide. Sodium chloride. Okay, And you're going to do that, like I said, I would identify whether or not it was ionic or covalent. Go back, look through, okay? All right. Again, writing chemical formulas, it's just basically that, just practicing and making sure that you know how to write them. If there's any that you don't understand how to do, you guys, just circle them, and then when I get back, we will go over them. But I really need for you guys to get this done, knock it out. Go back and rewatch parts of this video if you're not for sure how to do something. Yeah, and I think that's our entire packet. So have any questions, shoot me an email, and I will try to get back to you via email. Please be good for the sub. Talk to you later.